Hello everyone, welcome back to my channel. So my name is Arijit and this is our third session related to SCM Analytics. So today we are going to generate a graphical model by using the problem statements. So let me share my screen. I hope that you are able to see my Excel file, right? Okay, so before we start today's session, let me just recall what we did in our second session. So in our second session, basically we solved a problem related to production mix and we find out the optimal solution by using the Excel solver. So as per Excel solver, the maximum quantity of the exterior paint that we can produce is 2.5 ton and the maximum production of the interior paint should be 3 ton per day to generate a maximum profit of 24.5 every day. So this is the maximum profit and this is the maximum production plan that we can do by considering all the input parameters and the constraints. Okay, so this is as per the Excel solver. So let us see what we can get from the graphical model. Okay, so today we are going to learn two things. First of all, how to generate a graphical model from these problem statements. And second of all, we are going to validate both the results. That is the result that we are going to get from the graphical model and the result that we have already got from the Excel solver. So to generate the graphs, we are going to use this website for today. And don't worry about the link of the website. I am going to mention the link in the video description only. So to generate the graph, we need to go to the tab Graphing Calculator. So in this tab, we are going to generate the graphs. Okay. Till second session, we discussed up to this. So basically, we converted this English language into mathematical language. Okay. Now, this two extra constraint we have added today. Why? Because if you remember it, what we did in the last session, in our second session, while solving the issue with the solver, we take this option. So when we take this option, make unconstrained variables non-negative, it means it will not allow any type of negative production plan for the exterior paint and the interior paint. Since today we are not going to use the Excel solver to solve this issue, I have added this extra to constraint, which simply implies quantity of exterior paint, that is X, should be greater than equal to 0. That means we are not going to allow any negative production plan for exterior paint. Similarly, for interior paint, Y, it should be greater than equal to 0. So that means we are not going to allow any type of negative production plan for interior paint as well. Now, what is the formula of the objective? So in this problem, the objective is to maximize the profit that we have already discussed. Okay. Now, what is the profit per ton for exterior paint? That is 5 rupees. And for interior paint, that is 4 rupees. That means 5 multiplied with quantity of exterior paint, that is X, plus profit of interior paint 4 multiplied with the quantity of the interior paint Y. So this is our formula for objective. Okay. Now I am going to plot this entire mathematical model in this side to generate the graphical model. Okay. So what is our first constraint? The first constraint is 5x plus 4y less than equal to 30. 5x plus 4y less than equal to 30. Since we are not considering any type of negative production plan for exterior or the interior paint, we are only going to consider the positive side. Okay. So from 0 to 6 up to this. Okay. So this is our entire solution area, which we got after adding the first constraint. Okay. So let me just do some settings here. Yeah, so I am going to change it as a name value, and also let me apply some different colors. Okay, so you can able to see after adding the first constraint 5x plus 4y less than equals to 30, this is our entire solution area. Okay. Okay, now what is our second constraint? Second constraint is 2x plus y less than equal to 8. That means 2x plus y less than equal to 8. So after adding the second constraint, our solution area got reduced from 0 to 6. Now it is 0 to 4. You can see this is our solution area as of now. Okay, so let me just do some changes in the color. This is not visible. This is visible. Okay, yeah. Okay, so now you can see our solution area got reduced from 0 to 6 to 0 to 4. And by the way, this is the x-axis and this is the y-axis. Okay, now let me put the third constraint. The third constraint is y minus x less than equal to 1. So y minus x less than equal to 1. So again, let me do some changes in the setting. Okay, so this is the third constraint. And let me just change the color as well. Okay. So this is our third constraint. And after adding the third constraint, our solution area is this now. 0 to 1 up to this. Okay, so again it got reduced further. Okay, now what is the fourth constraint? The fourth constraint is y less than equal to 3. So let me add this one as well. Y less than equal to 3. So this is our fourth constraint. Let me just do some changes in the settings. Okay, let me just change the color as well. Not this one. Ah, okay, fine. So y less than equal to 3. So now what is our solution area? This is our solution area. Okay. After adding 1, 2, 3, 4 constraint. So starting from 0 up to this, up to here, this one, and this one. So this becomes our solution area. Now let me add these two constraints, x greater than equal to 0 and y greater than equal to 0. So x greater than equal to 0. Sorry. X greater than equal to 0 and y greater than equal to 0. Okay, so we have added all the constraint as of now. Okay, and what is the okay, let me just zoom in. So how many different points we are getting now? 1, 2 point, 3 point, 4 point, 5 point. So as of now, we are getting 5 points. Okay, so let me just recount it once again. This is the first point, second point. So we are just going to take the intersection points. Okay, and this is our solution area as of now after adding all the constraint. Okay, so this is our solution area. Okay, so how many points we are getting? 1, 2, 3, 4 and 5. Now what are the coordinates of these points? So if you see, the coordinate of this point is 0, 0 because it is starting from 0, 0. Okay. So first coordinate point is, let me write it down. First coordinate is 0, 0. Okay. Now what is the second coordinate? The second coordinate is 0, 1. Why? Because the x-axis is 0 and y-axis is 1. That means the coordinate of this point is 0, 1. So second coordinate is 0, 1. What is third coordinate? Third coordinate is from the x-axis, it is 2. And from y-axis, that is 3. So that means the third coordinate is 2, 3. Okay. What is the fourth coordinate? From x-axis, you can see it is 2.5. This one, 2.5. And from y-axis, that is 3. So this is the coordinate of this point. Okay. So 2.5, this is 3. Okay, and what is the coordinate of the fifth point? The coordinate of the fifth point is 4, 0 because x-axis is 4 and y-axis is 0. This is the y-axis is 0. Okay. So let me write it down. 4, 0. So from this graph, from this solution area, we actually got 5 points. Okay. This is the first point, which is 0, 0. This is the second point, that is 0, 1. So you can see the first point is 0, 0. Second point is 0, 1. This is the third point, which is 2, 3. This is the third point, which is 2, 3, the coordinate. This is the fourth one, which is 2.53. This is the fourth, 2.53. And this is the fifth point, whose coordinate is 4, 0. Fifth point, whose coordinate is 4, 0. Now let us see. This is our profit formula or the OFB formula. Okay. So if we use this coordinate, obviously for the first coordinate, you will not get any result. Okay, because the value of the coordinate is 0, 0. So let's try with the second coordinate. Okay. So what should be the value? 5 multiplied with what? This one plus 4 plus 4 multiplied with what? This coordinate 1. That means you are going to get 4. Okay, let me write here only. So this is the formula OFB result. Okay, so OFB result for the first one is 0, for the second one is 4. For the third one, we are generating a profit of 22 rupees. For the fourth one, we are generating a profit of 24.5 rupees. And for the fifth one, we are generating a profit of 20 rupees. So from where we are generating the maximum profit? We are generating the maximum profit from this coordinate, which is x-axis is 2.5. Now, what is the meaning of x? The meaning of x is quantity of exterior paint. That means as per graphical model, exterior paint quantity should be how much? 2.5. And for interior paint quantity, what should be the quantity? 3. So as per graphical model, if we produce exterior paint 2.5 ton per day, and if we produce interior paint 3 ton per day, then we can able to secure the maximum profit, and the profit is 24.5 rupees. Okay. Now, if you see, These results we got when we solve the problem using Excel solver. And this is the result that we have got while solving the problem using graphical method. That means the results of both the models are same. For Excel solver also, the exterior paint and the interior paint quantity are 2.5 and 3 tons respectively. And for graphical models also, the results are same. So basically we found out the results which we got from the graphical model are same what we got from the Excel solver. Okay. So yeah, so that is the end of today's class. I hope that you have enjoyed the class, but in case if you want me to go through the graphical model once again, let me know. Otherwise, in the next session, we are going to start the problems related to the transportation or the logistic issue. Okay. See you in the next session.